Hello and welcome to my video, lesson 9.5b. I'm kind of just adding this in afterwards about general form answers to trig equations. So this is going to be a little bit more in depth on general form and some odd cases of it. And so if you take a look here, hopefully this video helps. Okay, so we are going to be solving some questions here. You can solve it multiple different ways. I'm going to say this first one, you can solve this with a difference of squares, or you can solve it using a regular, opposite operators, opposite bedmass, whatever feels more comfortable. I'm going to show you both really quickly. So if it's a difference of squares, you square root both parts, and you'd write 2 sine x plus 1, 2 sine x minus 1, and that's one option. The other option is to move this minus 1 across the equal sign, and you get this, and then you can put in sine squared x, and you can divide by 4, then you can square root both sides, and so you get the square root of that, which means it's plus or minus because it's square rooting a square, and so it's the square root of 1/4, which is 1/2. So regardless of how you do it, and again, this would be the, I'm not going to show you the work here, but this would be that sine x equals -1. This would tell us that sine x equals +1. So, 1/2. +1/2, -1/2. So it matches regardless of how you do it. But the key that I want to point out is this statement here is saying positive or negative 1/2. So when we draw this on the unit circle, we have it in all 4 quadrants. So it's here, and it's sine, so it's the smaller one. Here, 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 and here. Now, when you do this in general form, you're going to notice that this is pi over 6. This is 5 pi over 6. This is 7 pi over 6. This is 11 pi over 6. Now, if you're doing this in general form, you can simplify this because these two match each other. They're 180 degrees from each other. And these two match each other. They're 180 degrees from each other. So if we do this, we can write x equals pi over 6 plus pi, because it's 180 degrees, from each other, pi k, where k is an integer. Okay, the other part of the question, the other part I circled, is 5 pi over 6 plus pi, again, because it's 180 instead of 2 pi, it's just pi, and then it's k, where k is an integer. And so this is our final answer for this question. All right, you can pause the video now, try this for yourself, and see if you get the same answer that I do. Okay, so this is going to be a fun PSA 2 question. I'm saying fun because it's going to be a relatively easy one. You're looking for a pattern here, and it's going to be something like this. Now, they both have to get us to 1, but the bigger number is going to be the plus. So it's going to look like this. Now, this allows us to find that sine x on the left one is a positive 1/2, and sine x for the other one is a -1. So if we draw this on our unit circle, how does this look like? Well, the sine x being -1 would be this position, the 1/2 would be this position, and the other 1/2 would be this position. And hopefully by just having 3 of them on the screen right now, you can see that there's a bit of a pattern happening here. There is a distance of 120 degrees. Oh, did I do radians in the last question? I totally did, because the question said degrees. Whatever, that's fine. We'll do degrees here. So this is a total distance of 120 degrees going around from part to part to part. But it's not starting at 120, it's starting at 30 degrees. Okay, so we're going to write x equals 30 degrees plus the 120 degrees, k, again, where k is an integer. And this answer does actually cover all three parts. Okay, sometimes that happens. It's kind of a weird example, but that's why I put it here. All right, let's take a look at our next two questions and see if we can solve these. Now, this one does have a trig identity in it, but it's not a complicated one. It's 2 sine x cos x. It's the double angle identity. And if we are trying to solve for x, the 2 is actually just going to divide out. And like 0 divided by 2 is just 0 still, so nothing changes. So what we can say is that sine x equals 0 and cos x equals 0. Well, this is wonderful because it also goes on the unit circle in a funny special way, and there's a reason why I did that. These two are both where y equals 0, so that's here and that's here. This one is in two positions where x equals 0. That's here and that's here. So this one, if you look around the unit circle, it's a 90 degrees there, a 90 here, a 90 here, a 90 here. It's a 90-degree bend every single time, starting at 0 degrees. So we can write our answer as x equals 90 degrees. Oh, now I'm doing degrees when it should be radians. Pi over 2, k, where k is an integer. All right, pause the video now and try it for yourself and see if you get the same answer that I do. Okay, hopefully you can see that this is going to be tan squared x, and then when you minus the 4 over, it's going to be a 1. And when we divide that, or square root that to get the tan x by itself, it's a square root of 1, which is positive or negative 1. We're squaring a square root, or square rooting a square, so we're going to get a positive and negative result, which is wonderful because if we look around our unit circle, where is positive tan? Where tan is 1, it's there and there. Where is it negative? It's there and there. And this happens every 45 degrees, or in this case, where tan, sorry, in radians, this is going to be pi over 4. And so it starts at pi over 4, but again, like in the last question, this is a 90 degree. This is a 90 degree, et cetera, et cetera. So it's always going 90 around the circle. So our answer is going to be x equals, and I'm kind of confusing things because I did degrees there as well, pi over 4 plus 90, which is pi over 2, k, where k is an integer. I hope this video helped you better understand the general form, both in radians and degrees, and good luck.